Hi everyone, in this video I will be starting this 1973 AP Calc AB multiple choice. And as always, I'm going to give a disclaimer that the content that was covered in AB back then might not be the same as when you're watching this video. So I'll leave it up to you as to check whether some of the problems are actually the content or what the problem is trying to test is actually covered in what you're learning. Okay, but regardless, I'll be solving all the problems in this AB exam, okay, to the best of my ability. All right, so let's begin. Also, one more thing, I will probably split this up into multiple parts, okay, so that it's not a huge, long video. Okay, so let's begin. Number one, we have this integral x cubed minus 3x dx. This is simple power rule, so we simply just do x to the fourth, excuse me, x to the fourth divided by 4 minus 3x squared over 2 plus c. Okay, hopefully that's visible. Which one is that here? That looks like choice E. Okay, simple power rule to find the antiderivative. Okay, this is about composite function. It looks like f of x is this, g of x is this, then g of f of 5 is, so wherever there's x in g, you plug in f. G is just a constant, so no matter what f of x is, g is always going to be 5. So this is easy. The answer is E. The slope of the line tangent to the graph of y is ln of x squared. At x is e squared is, so slope of the line tangent, that should signal derivative. We want to find y prime. Okay, what is y prime? Let me see if I can squeeze it here instead of showing my work that I did in a previous attempt. Okay, so y prime, we would need the chain rule. So first we take the derivative of log. It'll be 1 over the argument squared, okay, times derivative inside, which is 2x. Okay, we simplify. This is what? 2x on top, x to the fourth on the bottom. So this is the same thing as 2 over x cubed. Actually, did I do this right? I did not do this right. I don't know why I did the log as this. Okay. I'm like, this doesn't seem like what I did before. Okay. So let's just go here, okay? Derivative of x is 1 over the argument, no square. So that was my bad. So derivative of ln is 1 over x squared, or 1 of the argument, so 1 over x squared, times derivative inside, that's 2x. Okay, we evaluate this at x is equal to e squared, because that's what we want, okay? We can first simplify. It'll be 2 over x, evaluate x is equal to e squared, which is 2 over e squared. So that's B. Okay, number 4, if f is x plus sine x, f prime is, this just, we just differentiate one by one. Derivative of x is 1, derivative of sine is cosine. 4 is A. Number 5, if f is e to x, which of the following lines is an asymptote to the graph of f? This is very easy. We know how e looks. E looks something like this. So we know there's a horizontal asymptote at y is equal to 0. So 5 is A. If f of x is x minus 1 over x plus 1 for all x not equal to 1, f prime of 1 is what? Okay, so f prime, we need to use the quotient rule here. Okay, so I wrote f again here, quotient rule. When we find the derivative, that's bottom d top minus top d bottom over bottom squared. So bottom, that's this, d top, derivative of the top is just 1, minus top times d bottom, that's derivative bottom, that's just 1 again, over bottom squared. Okay, let's simplify. This one is just x plus 1. This one would be minus x plus 1 after we distribute this negative sign. Okay, the bottom would leave the same. This x and this x would go away. This x and this negative x, sorry. This we have 1 plus 1, so that's 2 over x plus 1 squared. Okay, we leave the bottom same. Evaluate at x is equal to 1. That's equal to 2 over 2 squared, which is 2/4, which is half. Okay, let's move on. Which of the following equations has a graph that is symmetric with respect to the origin? This should sound like it's an odd function, which is f of negative x is negative f of x. That's the definition of an odd function. Which one's an odd function? If we just eyeball it, it's clearly b. You could do this test also. If we plug in x is negative x here, we get negative x to the fifth, which is negative. The sign is negative, but then we have another negative, so it becomes positive x to the fifth, and then we plug in negative x to here, we get minus 3x. So that's the negative of this guy. Okay, this is clearly even. This is neither even nor odd, I believe. This is neither even nor odd either, I believe. And this one is neither even nor odd, I believe. So this one's the clear answer, B. Okay. Particle moves in a straight line with velocity v of t is t squared. How far does the particle move between the time t is 1 and t is 2? Conveniently, v of t is always greater than 0, so we don't have to worry about the sign. It's always moving in one direction. Okay. How far does the particle move between times t1 and 2? This should, how far does the particle move? This should signal integration because we have velocity. We want to get the distance traveled. That's the integral of velocity. Okay. So again, I just said if it's distance traveled, it's an absolute value of velocity. The velocity doesn't change sign when t is between 1 and 2, so we're good. Okay. So integral from 1 to 2, t squared dt. I cannot talk today. This one, after fundamental theorem calculus, power rule is t cubed over 3. So that's here, evaluate from 1 to 2. So this is fundamental theorem calculus. 2 cubed is 8. 1 cubed is 1, so that's there. The 1/3 is still there. Inside the parentheses is 7, so it becomes 7/3. If y is cosine squared 3x, then dy dx is, well, we can rewrite y as cosine of 3x, this little guy squared. Okay, this helps you visualize. To do the chain rule, because the chain rule would be, first do the power rule, it would be 2 cosine 3x, and then times derivative of the inside, which is, what's the derivative of cosine? That's negative sine 3x, and then times derivative of the inside of this, so what's the derivative of 3x? That is 3. Okay, so we get a minus 6 sine 3x cosine 3x. Okay, so 9 looks like it's A. Okay, number 10, derivative of this attains its max value at x is equal to what? So it's asking, you got to read it carefully, when f prime has its max. Okay, that's what it's asking. So if f is this guy, f prime, we just do power rule 4/3 x cubed minus x to the 4th. So we want to find the maximum here, so we differentiate once more. F double prime would be 4x squared minus 4x cubed. Again, we just do the power rule. We set it equal to 0 to find our critical points. So here we can factor out a 4x squared. Then when we do that, we're left with 1 minus x is equal to 0. Okay, so our solutions are 0 and 1. Okay, we do the, it's weird to say, we do the first derivative test on the second derivative. Okay, so we want to find the sign of f prime in these intervals. Okay, when you plug in a number less than 0, this guy's always positive. This guy would be 1 minus some negative number, so that becomes positive. 2 positive make it positive. Plug in a number between 0 and 1, like half. This guy's always positive. 1 minus half is positive. Sign is positive, because positive times positive. Plug in a huge positive number. This guy's always positive. 1 minus a huge positive number would make this negative. Positive times negative is negative. The second derivative changes sign at x is 1. It changes from positive to negative. So we know that there's f prime has a max at x is equal to 1. 10C. Okay. If the line 3x minus 4y equals 0 is tangent in the first quadrant to this guy, then k is equal to what? Okay, so tangent, that should signal derivative. What do we take the derivative of? So this is the tangent line, so it'll be tangent to this curve. So we want to take the derivative of this guy. Okay, so Where did I work this out? Okay. So again, this is our curve. This line is tangent to this guy. So let's take the derivative of this guy. So it will be just 3x squared by the power rule plus k. K is a constant, so the derivative of k is 0. Okay. So this is y prime. Okay. You can ignore this part for now. We want this. This is the tangent line, right? We want the slope of this line. So let's get it in slope-intercept form. So 3x is equal to 4y. Move the 4y to the other side. Divide by 4 on both sides. Y is equal to 3/4 x. So we know the slope is 3/4. So we want to set the derivative of our function to equal to the slope of this line. Okay, so which is 3/4. So we solve for x now. X squared is 1/4. I just divide by 3 on both sides. So when we square root both sides, we get x is plus half and negative half. We can eliminate negative half because it says first quadrant. So x is half. Okay. We want the value of k, so we're not quite done. We know the x coordinate. What's the y coordinate of the points? So we can use the tangent line because the tangent line will touch at the graph at that point. So we plug in x is half here, so 3 times half minus 4y is equal to 0. We solve for y. Over here is 3 halves, so 4y is equal to 3 halves. Y is equal to 3/8. Okay, so we have the x and y coordinate now. We plug back into here now. Okay, so y is 3/8, x is half, so half cubed plus k. Now we solve for k. So 3/8 is 1/8 plus k. So k is 2/8, or it's 1/4. Okay, so this was a little tedious, but not hard at all. Okay, if f of x is this guy, f of 2 is 3, f of negative 2 is negative 37, what is the value of a plus b? I believe they won't ask this in AB anymore, but this is simple. We just plug in. We have 2 points. We plug in the first point, 2, 3. We would get this equation. Okay. And once we simplify, I'll let you read it on your own. You can pause the video. Once again, I don't believe they'll ask this, but we plug in the first point, we get this equation after simplification. We plug in the second point over here, we get this equation after the simplification. 2 equations, 2 unknowns, we can solve it. Okay, so a is negative 3, b is 2, so it asks for a plus b, so negative 3 plus 2 is negative 1. Okay, so you can pause the video yourself to see my work for that, but I won't spend time on that. Acceleration alpha of a body moving in a straight line is given in terms of t by alpha is 8 minus 6t. If the velocity of the body is 25 at t is 1, and if s of t is the distance of the body from the original at time t was s of 4 minus s of 2. Okay, we're given acceleration, we want this guy. So we probably need to integrate acceleration to get velocity and then velocity to get position. Okay, that's my thought process. So, and they give us the initial condition that velocity at t is 1 is 25. Okay, so v of 1 is 25. Okay, so alpha acceleration is this guy. Let's find velocity. That's the integral of acceleration. We just do the power rule. So it'll be 8t minus 3t squared plus c. So we do the power rule on this guy. Okay, then we plug in our initial condition. V of 1 is 25. So wherever there's t, we plug in 1. That'll be 8 minus 3 plus c. So 25 is equal to 5 plus c, or c is equal to 20. So our particular solution for velocity is v of t is 8t minus 3t squared plus 20. So we plug in c back into our general solution here. Okay. Now, to get s of 4 minus s of 2, we can use fundamental theorem of calculus by a definite integral. So we can integrate the velocity from 2 to 4, v of t dt. Okay, that's position at 4 minus position at 2. Okay, so we just need to solve the left-hand side of the equation. So again, 2 to 4, this is our v of t. So I plug that in there, in the integral, okay? This is again power rule, 4t squared minus t cubed plus 20t, evaluate from 2 to 4. We plug in the upper limit, that's these terms. Plug in the lower limit, that's these terms. I won't go over the math. You could check your You can pause the video to check. The answer is 32 though. Okay, so the key here was they give us acceleration. We need to get velocity first, and a particular solution of velocity because they give us the initial condition. And then we can integrate velocity to get position, but we specifically, to get s of 4 minus s of 2, we can just set up a definite integral. Okay. Number 14, f of x is x to 1/3, x minus 2 to 2/3. For all x, domain of f prime is what? So to find f prime, we differentiate this. We would need product rule. Product rule is first d second plus second d first. Okay, so f prime first, the second derivative of this guy, we would need first the power rule, 2/3, x minus 2 to the 2/3 minus 1, which is negative 1/3. Okay, times derivative inside, that's just 1. Okay, derivative inside, we need that because of the chain rule. Okay, plus second d first. So second d first was the derivative of this. Again, power rule, 1/3, x to minus 2/3 power. Okay, so we simplify. So here I just combine all the terms. So 2/3 I pulled outside, x minus 2 I moved to the bottom, and the x to 1/3 on the top. Okay, over here again I left a constant out in the front. This is on top, this is on the bottom. Okay, so we know when we just even reorganize it like this, we can look at the domain. This term, x cannot be equal to 2 because we'll divide by 0 there. Over here, x cannot equal to 0 because we'll divide by 0 there. Okay, so x cannot equal to 0 or 2. That's D. Area of the region bounded by the lines x is 0, x is 2, y is 0, y is e to the x divided by 2 is what? Okay, so you should be able to visualize this region very easily. These are just two vertical lines. This is a horizontal line. Exponent, we know how that looks. So here's a very rough sketch. Here's x is 0. Here's x is 2. Again, I just said there are two vertical lines. E to x looks something like this, and then y equals 0 is the x-axis over here. Okay, so this is our region R. Okay, where we asked to find area. Area is the integral. So integral from 0 to 2. The upper curve is the exponent, e to the x over 2, minus lower curve, which is just y is equal to 0, so minus 0. E to x over 2 dx, that's the integral. Okay, we solve this. It'll be the antiderivative of this is 2e to the x over 2. You could do a substitution if you want. This should be easy enough to do in your head. You could always just differentiate this. Check if you get back this. If you differentiate this, it'll be 2e to x over 2 times half. So the half and the 2 would cancel, right? So we know that we did it right. Okay, we evaluate from 0 to 2. So that's just 2 times e to the 2 over 2, which is e to the first power, which is e. And then we plug in 0, that's e to 0, which is 1. Okay, so it's 2 times e minus 1. Number of bacteria present in a culture is growing at a rate of 3000 e to 2t over 5 per unit of time t. This probably sounds like a related rates problem. Okay, at t equals 0, the number of bacteria present was 7,500. Find the number present at t is equal to 5. Actually, not quite related rates, but when you see that number of bacteria in a culture is growing, this should signal this is the derivative. Okay, this is a rate. So if we call the number of bacteria b, this is dB dt. This is the function. 3000 e to 2t over 5 is equal to dB dt. Okay, so that's what I did over here. Okay, I called it dB dt. At t is 0, the number of bacteria was 7,500. So they give us b of 0 is 7,500. Okay, find the number present at t is 5. So we're interested in b of 5. Okay, so we want to find b of t from here. So we just integrate both sides. B of t is, we find the integral or antiderivative of this. Again, you could just do a little substitution if you can't do it in your head. It would be 3000 times 5 halves e to 2t over 5 plus c. Again, we can just check that if we differentiate this, we get 3000 times 5 over 2 times e to 2t over 5 times 2/5. So that 2/5 and this 5 over 2 would cancel. So we're left with this. So we know that we got it right. okay? Excuse me. Okay, we can simplify this too. So this is 5 times 3 is 15, so it's 15,000. 15,000 divided by 2, that's 7,500. So 7,500 e to 2t over 5 plus c, okay? So they give us b of 0 is equal to 5, so we can use that to find this c. b of 0 is 7,500, which equals to, we plug in t as 0. So 7,500 e to the 0 plus c, e to the 0 is just 1, so we can subtract the 7,500 on both sides. We get c is equal to 0. Okay, so that's easy. B of t then is c is 0, so we plug in c as 0 there. We just let the 7,500 e to 2t over 5. Okay, so we plug in 5 for b of 5. B of 5 is 7,500 e squared. Okay, so that is choice C. Okay, what is the area of the region completely bounded by the curve y is negative x squared plus x plus 6, and the line y is equal to 4. Okay, so this area we need to find upper curve and lower curve, and we need to find points of intersection. Okay, so it will help to sketch this out. Okay, we know that this is a parabola that opens downward. Okay, hopefully you do know that this is x squared, so you should know that it's a parabola. It's opening downward because there's a negative sign out in front. Y equals 4, that's the horizontal line, so it'll look something like this. Okay, we need to find points of intersection. Okay, to find that would be our limits of integration. So we just set 4 is equal to negative x squared plus x plus 6. Okay, we set this and this equal to each other. Okay, so let's solve for x. So 0 is equal to, so I move the 4 to this side, minus x squared plus x plus 2. I factor out a negative 1 from all the terms, so negative times x squared minus x minus 2. This you can factor as x minus 2, x plus 1. Okay, so we know that the x coordinates of the intersections are minus 1 and 2. Okay, and then the y coordinates are obviously 4 because that's where the line y is equal to 4 is. Okay, so the upper curve is the parabola, lower curve is y is equal to 4. Okay, so we found our limits of integration, we found the upper curve, we found the lower curve. Okay, so let's plug it in. Integral from negative 1 to 2, that's what we just found. Upper curve, I just said it's the parabola, minus lower curve, that's the straight line. Okay, so we simplify, it's minus x squared plus x plus 2 when you add 6 and negative 4 together. Okay, so this is a simple power rule. Negative x cubed over 3 plus x squared over 2 plus 2x. We evaluate from negative 1 to 2. Fundamental thing in calculus, I won't go through all the math. In the end, you get 4.5 or 9 over 2. Okay? You can pause the video to see the tedious math. Okay? This is very easy. Derivative of arc sine of 2x. We need to chain rule. Okay? So we first take the derivative of arc sine. What is that? That's 1 over square root of 1 minus the argument squared times derivative inside. Derivative of 2x is just 2. Okay? That's equal to 2 over square root of 1 minus 4x squared. So 18 is D. Okay. I'm a bit lost on where all my work is. Did I just skip some problems? I'm confused now. To 18, we're on number 19. Okay, sorry. Okay. Suppose I'll probably finish this page and call it apart. Suppose that f is a function that is defined for all real numbers, which is following conditions assures that f has an inverse function. Okay, so immediately when I think inverse function, remember there's a test for if an inverse exists. It's the horizontal line test. Remember the vertical line test, that's for if something is a function. Okay? The horizontal line test tests if something is 1-to-1. Or in other words, if there is an inverse. Okay? So let's go for each of the choices. Okay? the function f is periodic. Would that ensure that f has an inverse? Well, I already can think of a counterexample. So if you can think of even one case that disproves it, then it's false. Okay, so remember the key is horizontal line test. Okay, for if something is periodic, let's think what's a periodic function like sine x. How does the sign look? It looks something like this. Okay, this is sine x. This is periodic, but it fails the horizontal line test. Sine x, we know, doesn't have an inverse. In fact, when we talk about inverse of sine, we had to restrict the domain, if you remember, in Algebra 2 or pre-calculus, okay? So we know this is false. The graph of f is symmetric with respect to the y-axis. We can think of another counterexample real quick. If y is equal to x squared, this is symmetric about the y-axis, correct? Again, it fails the horizontal line test. There's no inverse. Okay, f is concave up. Well, this example also works. X squared is concave up. There's no inverse though for x squared. The function f is strictly increasing. I believe that is true. We'll skip that for now. Function f is continuous. X squared is continuous everywhere. But again, inverse is not true. So process of elimination, choice D. Okay. This does make sense too, because if it's strictly increasing, then there will be no repeating y value. So that would ensure that it's 1-to-1. Okay. If capital F and lowercase f are continuous such that capital F prime is lowercase f for all x, the integral from a to b, f of x dx is, this should look very familiar to fundamental theorem calculus, okay? Here, if we differentiate f, you get f. So we know that capital F, is the antiderivative of f, lowercase f. Okay? So when we do the integral from a to b of lowercase f of x dx, that is simply capital F of b minus capital F of a by fundamental theorem calculus. So 20 is D, not C, sorry, it's D. Okay? This one, integral from 0 to 1, x plus 1, e to the x squared plus 2x dx. Okay? So the main technique you learned in AB should be substitution. So let's try that out. Okay? Let's try to substitute the argument of the exponent. So u is x squared plus 2x. Okay? So du would be 2x plus 2 dx. I just differentiated. Okay? Now, we have something that looks a little bit like the signature, x plus 1 dx. If we factor out a 2 from here, we get 2 times x plus 1 dx. So x plus 1 dx, x plus 1 dx, that's good. So we can do a substitution, okay? So if we do a limits of integration, when x is 0, we just plug in here, u is 0. When x is 1, u is 1 squared plus 2, which is 3, okay? Let's do this one first. E to the u, that should be easy, because this is u, okay? How about x plus 1 dx? X plus 1 dx is du over 2. So du over 2, but I can pull the half to the front, okay? This is a very easy integral. That's just e. So it's half e to the u. Evaluate from 0 to 3. Do fundamental theorem calculus. That is half times e cubed minus e to 0, or 1, okay? So half times e cubed minus 1, that is, looks like b. Okay. Given the function defined by f of x is 3x to the 5th minus 20x cubed, find all values of x for which the graph of f is concave up. Okay? Concavity, that immediately signals I should find the second derivative. Okay? So let's find f prime first. Let me see if I can squeeze it in here. F prime would be, we used a power rule, 15x to the 4th minus 60x squared. Let's find the second derivative now. F double prime x is, what's 15 times 4? That should be 60x cubed minus 120x. Let's set this equal to 0 to find the critical points. We can factor out a 60x from both terms. Then we will be left with x squared minus 2. Okay, so our critical points would be x is negative root 2, 0, root 2. Okay, this is 0 and this is plus minus root 2. Okay, so let's do our second derivative test. Okay, we plug in some number much less than negative root 2, a huge negative number. What's the sign of f double prime? So we can plug it in here. Plug in a huge negative number here. That'll make this term negative. Huge negative number squared, that's positive. Minus 2, that's still going to be positive. Okay, so negative times positive, that is negative. Okay, we plug in like negative 1, that's in between these 2 points. Okay, this term would be negative. This term would be what? It'll be 1 minus 2, which is negative. So negative and negative, 2 negatives make a positive. Okay, we plug in positive 1. This would be positive. This would be negative. Positive and negative make a negative. Plug in a huge positive number. This is positive. This guy would be positive, positive. Okay, so it's concave up when f double prime is greater than 0. So it's in this interval and this interval. So from minus root 2 to 0 and also greater than root 2. So 22 is B. Okay. It's now about half an hour, so I'll stop here for this part. So please give this video a like if it was helpful, and please subscribe to the channel to look out for the next part or 2. Okay, and again, I apologize that I was a little rusty in the beginning of this video, so apologize for the mistakes, but hopefully it was still helpful after I fixed them.